Hi, everybody. It's Professor Mitchell. We're starting a new chapter today, Chapter 5 on exponents and polynomials. We'll start with Section 5.1 on exponents, quite a few objectives in this section. We're going to evaluate exponential expressions, use the product rule for exponents, use the power rule for exponents, use the power rules for products and quotients, use the quotient rule for exponents, and define a number raised to the 0 power. And then finally, we'll decide which rules to use to simplify an expression. And I believe every section in this chapter falls under SLOA, which is perform mathematical operations on algebraic expressions. All right, so we'll start with a little review of evaluating exponential expressions. So these are the examples I have for you. I'm going to switch over to the tablet. All right, so we'll start with these two examples, and I think I've talked about this concept to you before. Letter A, we have the opposite of 3 squared, and in letter B, we have the square of -3. So hopefully you know the difference between those two things. I'm going to start with letter B. Letter B, again, is the square of -3, so that means multiply -3 by itself. And of course, -3 times -3 is 9. Letter A is not the square of -3. It is the opposite of the square of 3. So what this means is 3 times 3, and then change it to the opposite. So that's going to come out to -9. And the reason I bring this up is because sometimes people do one of these things when they mean to do the other one. So it's important to be aware of the difference and do the one that you mean to do, right? Okay, next we have the 5th power of 0.2. So you could do this with a calculator. What I like to do is to explain that sometimes fractions are actually your friend. All right, if you think of that 0.2 as 2/10, and you write it as the fraction 2/10, then you have, and we're going to have an easier way to do the 5th power of a fraction just a little later in this section. But in the meantime, we have 2/10 times 2/10 times 2/10 times 2/10 times 2/10. I think I said that the right number of times. 2 times 2 times 2 times 2 times 2 is 32. 10 times 10 times 10 times 10 times 10 is 100,000. And then if you put that back to a decimal, let's see. I'll let you get inside my head while I make sure that I put the correct number of zeros between the decimal point and the 3. All right, if the decimal point was here, that would be 32 over 100. Okay. So this would be over 1,000. This would be over 10,000. Let me try that again. Okay. Over 1,000, over 10,000, over 100,000. Okay, so as a decimal, this is 0.00032. And again, you could also do this with the calculator. All right, the square of -1/9. That reminds me a little bit of letter B. It means -1/9 times itself. Okay. A negative times a negative is positive. 1 times 1 is 1. 9 times 9 is 81. All right, and then finally we have -4 times 3 cubed. So what I would do with that is just Maybe write it like this, or you can just even figure out what is 3 cubed. 3 cubed is 27. And -4 times 27 is -108. All right, so a little review of using exponents. So now we're going to get into our exponent rules for simplifying expressions with exponents. And we're going to start with the product rule. So I do like to talk a little bit about why do these rules work the way they do. I think that makes them easier to remember. It's always easier to remember something you understand than something you don't understand. All right, so suppose you were looking at this for the very first time, x squared times x cubed. If you just think about the meaning of x squared and x cubed, x squared is x times x cubed is x times x times x. So altogether you have 5 copies of x, which is x to the 5th. All right, so that makes it not too hard to believe that when you multiply expressions like this, a to the m times a to the n, you need to add the exponents. So in words, what this rule says is to multiply powers, you add exponents. All right, so the examples we're going to do for this rule are right here. I think that's all of them. Yeah. All right, so I'll switch over to the tablet. All right, so first we have the 7th power of -5 times the 6th power of -5. According to the product rule that we just talked about, that would simplify to -5 to the power 7 plus 6, which is -5 to the power 13. Okay, and that's how they want us to leave the answer. The 13th power of -5 would be a pretty big number. Okay, so we'll just leave it like that. Next, we have a squared b times a to the 13th, b to the 17th. So what I'm going to do is write the a factors next to each other, and I'll write the b factors next to each other. All right, by the product rule, a to the 2nd times a to the 13th is a to the power 2 plus 13. And then remember, there is an invisible 1 right here. So that means that b times b to the 17th is b to the power 1 plus 17. Final answer is a to the 15th, b to the 18th. All right, and finally we have 12x to the 5th times the opposite of x to the 6th times x to the 4th. All right, so first I'm going to multiply my numerical coefficients together. We have a 12 and this is a -1. So we'll have a -12 out front. And then the product rule does apply to more than 2 factors. So if you're multiplying x to the 5th times x to the 6th times x to the 4th, for example, you can say that that's x to the power 5 plus 6 plus 4, which gives us a final answer of -12x to the 15th. All right, back to the presentation. All right, the next rule is the quotient rule for exponents, and I bet I can get you to guess what this says. So remember that the product rule says to multiply powers, you add exponents. The quotient rule talks about how to divide powers. So guess what you do with the exponents when you're dividing powers? You're going to subtract them. So what the quotient rule says is that if m and n are positive integers and a is a non-zero real number, remember we can never divide by 0, then a to the m divided by a to the n is equal to a to the power m minus n. All right, so the examples we will look at for the quotient rule are right here. Let's switch over to the tablet. And we'll start with the 13th power of -6 divided by the 11th power of -6. Now, if you were to ask your calculator, what is the 13th power of -6 and what is the 11th power of -6, those are both great big numbers. So this problem is actually much easier to do without the calculator if you know the quotient rule, because the quotient rule says that this is equal to -6 to the power 13 minus 11. 13 minus 11 is just 2. All right, and you can tell without the calculator that the second power of -6 is 36. It's positive 36 because remember it's -6 times -6. All right, so now we have 9a to the 4th, b to the 7th, divided by 27ab squared. We can simplify the 9 over 27 like we always have. 9 divided by 9 is 1. 27 divided by 9 is 3. So that's going to give us 1/3. And then we're going to do, remember again, there is an invisible 1 right here. So that's going to simplify to a to the 4 minus 1, b to the 7 minus 2. Which gives us an answer of 1/3 a to the 3rd, b to the 5th, which can also be written as a to the 3rd, b to the 5th over 3. All right, either answer would be okay. All right, back to the presentation. So next we have the power rule for exponents. This talks about how to simplify expressions like the second power of x cubed. Well, the meaning of the second power of x cubed is that it's x cubed times itself. So if you think of it as x cubed times x cubed, by the product rule, that would be x to the power 3 plus 3, which is x to the 6th. All right, so the rule for simplifying these exponents is that you multiply the exponents. If you have positive integers m and n and a real number a, then the nth power of a to the m is equal to a to the power m times n. All right, and we will look at examples using all these rules in just a little bit. Next, we'll look at the power rules for products and quotients. If n is a positive integer and a and b are real numbers, and I guess in the second rule, b would not be able to be 0. All right, then the nth power of ab is equal to a to the n times b to the n. I kind of think of this as like a distributive property. I don't know if it technically is a distributive property, but it definitely works like one. And then the nth power of a over b is equal to a to the n over b to the n. So when you take the nth power of a product or a quotient, you can just raise each part of the product or quotient to the power n. All right, next we come to the 0 exponent rule. This one's a lot of fun. It's a little counterintuitive. And to convince you that this rule is correct, I like to talk about what is x to the 4th divided by x to the 4th. And there are two ways that you could do this. One way is just to say that any number divided by itself is 1. But the other way is to use the quotient rule. X to the 4th divided by x to the 4th would be x to the power 4 minus 4, which would be x to the 0. So assuming that both of those ways are correct, which they are, doing the problem one way gives you the answer 1. Doing the problem the other way gives you the answer x to the 0. So x to the 0 and 1 must be the same thing. In other words, anything except 0 to the power 0 is equal to 1. A to the power 0 is always equal to 1, as long as A is not 0. All right, so I believe now we have talked about all the exponent rules we're going to talk about in this section. I will review them with you at the end. In the meantime, we have these 5 examples. So I'm going to switch over to the tablet one last time. And we'll start with the third power of 2/3. So according to our new quotient to a power rule, this should just be 2 to the third over 3 to the third. 2 to the third is 8. 3 to the third is 27. That's it. The third power of 2/3 is 8/27. Next, we have -3 s to the 5th t times -7 st to the 10th. So I'm going to multiply -3 times -7 is 21. By the product rule for exponents, s to the 5th times s, which we're going to think of as s to the 1st, is s to the 6th. And then t times t to the 10th is t to the power 1 plus 10, which is 11. So we get 21 s to the 6th, t to the 11th. Next example. This one's kind of fun. 2x to the 0 plus the 0 power of 2x. Is there a difference between those two terms? Well, yes, there is. In the first term, the only thing that's being raised to the power 0 is x. So the x to the 0 part would come out to 1. But in the second term, the whole entire thing is being raised to the power 0. So that whole entire term would simplify to 1. And it would leave us with 2 plus 1, which is 3. All right, then we have the fourth power of 2ab over 6yz. The first thing I'm going to do is simplify 2 over 6. 2 divided by 2 is 1. 6 divided by 2 is 3. So now we have ab over 3yz to the power 4. By the quotient to a power rule, we will put the numerator to the 4th power and then put the denominator to the 4th power. And now by the product to a power rule, the 4th power of AB is a to the 4th, b to the 4th. And the 4th power of 3yz is 3 to the 4th, y to the 4th, z to the 4th. So the only thing that I would do with that at this point is just evaluate 3 to the 4th. 3 to the 4th evaluates to 81. So simplified answer, a to the 4th, b to the 4th over 81, y to the 4th, z to the 4th. And finally, we have the 5th power of 2x to the 6th y squared divided by -32 x to the 20th y to the 10th. So first, let's simplify the numerator. Again, I kind of think of this as a distributive property. So we have 2 to the 5th. And then we have x to the 6th to the power 5. Let me just write that down. And y to the 2nd to the power 5. Leave the downstairs alone for right now. All right, so the numerator simplifies to 32, x to the 30th, right? Because it's 6 times 5, that's the power rule. Y to the 10th over -32, x to the 20th, y to the 10th. All right, so I see some things that are going to simplify here. 32 and 32 cancel. Y to the 10th and y to the 10th cancel. So all I'm left with is the negative sign. And then by the quotient rule, this is x to the power 30 minus 20. Final answer is opposite of x to the 10th. All right, and that is just about going to do it for 5.1. I just want to end with showing you all of the exponent rules that we have so far. We have the product rule in number 1. We have the quotient rule in number 2. The power rule in number 3. In number 4 and 5, we have the product to a power rule and the quotient to a power rule. And finally, in number 6, we have the zero exponent rule. There will be one more rule coming in, I believe, section 5.5, which will be rule number 7. But in the meantime, that's going to do it for section 5.1, and we'll see you next time.